Okay, this is now our first example solving or simplifying algebraic expressions that have variable exponents. Okay, so we've done algebraic expressions where we have variables, but not where those variables were exponents. Okay, so as you can see here, our variable n is an exponent attached to a base. Right, so these type of questions will ask you to simplify because you aren't finding the solution to the expression, you're rather finding another form of this expression that I'd say looks better, looks less complicated. Okay, so the steps are broken up as follows. We get the bases to be the same. It's all about the base, just like it was earlier or in previous videos. So we get the same bases using equal, shift and fact. Alright, so we get those prime bases, then we place the value that we find in brackets, and then the final thing we do is apply exponent laws. Okay, so here's just a recap. If we have a power raised to another power, we multiply those values. Same thing here, if we have a power raised to another power, we say m times n and m times -1 to give us that. If we have the same bases multiplied, we add the exponents. And when we have the same bases and division, we would subtract the denominator's exponent from the numerator's exponent, generally speaking. Right, so let's go through our steps. We get the same bases. So we take 4 and we go equal, shift, fact, and that gives us 2 squared. And so in brackets we write 2 squared n minus 1. Okay, because the 4 is raised to the exponent n minus 1, so you need to put the 4 in brackets. We now do the 8. We take 8, we say equal, shift fact, we get 2 exponent 3, so we replace 8 with 2 exponent 3 and n plus 1. And lastly we have 1 over 2, right, but we want the same base, so 1 over 2 can be written as 2 to the negative exponent. Okay, so think of it as us taking this 2 to the 1 to the numerator and making it negative because of that move. So that becomes 2 exponent minus 1. And then in our denominator we have 32, so we go 32 equals shift fact, we get 2 raised to the 5th exponent, so we go 2 to the 5, and that has n as an exponent. Okay, alright, at this point we have all our bases the same. We place the values in brackets as can be seen there. I'm just going to highlight the second step being done, so we put those values in brackets. Okay, and now we need to apply our exponent laws. So let's have a look. We go 2 to the 2 squared, and then we multiply that with the n and with the minus 1, so that gives us 2 exponent 2n minus 2. Please be very careful here. The 2 must be multiplied with the n and the minus 1. Then we go multiplied by 2 again. The 3 must be multiplied by both those terms, so we go 2 3n plus 3 multiplied by 2 -1. Okay, so there we did exponent law, and the one that we just applied now was this one and this one. Okay, and now we do the same in the denominator. 5 multiplied by n, we have base 2 raised to the exponent 5n, and now we are going to end up doing laws 3 and 4 as is shown over here. So we need to now, because we have the same bases being multiplied in this numerator, we add these exponents, right? And because this one's in the denominator, we can go ahead and actually subtract that 5n straight away. So we keep our base 2, okay, and then we have 2n minus 2 plus 3n plus 3 minus 1, and then we subtract this 5n as well. Okay, and now it's just a matter of simplifying the like terms. So we have 2n plus 3n, which is 5n minus 5n, so the n's cancel. Okay, which leaves us with 2. So we got minus 2 minus 1, which is negative 3. Negative 3 plus 3 is 0. So we have 2 raised to the exponent 0. Okay, and so therefore the final answer here is 1. That means when we substitute a certain value in, our solution will be 1. Let's give that a try. So we go 4 exponent, let's make n 2, 2 minus 1, multiplied by 8, exponent 2 plus 1, remember n is 1, multiplied by 1 over 2. N can be anything you decide it to be, but I'm choosing 2, and there we have it. This solution is correct because for certain values of n, this will simplify down to 1, which I think is quite fascinating, that all these complicated numbers and variables and exponents and bases all simplifies down to just 1.